Assalamualaikum everyone. I'm Mahbur Hassan Shourab. In this video, I will talk about general equilibrium and welfare. Basically, our course title is Advanced Microeconomics. First of all, we will describe Waller's equilibrium allocation. Waller's equilibrium defined if aggregate excess demand equal to zero at that price vector equal to zero. Here price vector is super positive and price vector P star clears all market. The condition of Wallersian equilibrium allocation are two. The allocation is feasible, that means sum of all demand equal to sum of all endowment, and condition 2 is each agent is making an optimal choice from his budget set. If xi is preferred by agent X, then Pxi greater than P star xi. Now I will describe existence of Wallersian equilibrium. A Wallersian equilibrium price vector P star element the real number. The existence of Wallersian equilibrium depends on if the excess demand satisfies three conditions. Number one, Z is a continuous function, satisfies Euler's law and desirability. Combining Euler's law and definition of equilibrium, we have two useful propositions. Number one, market clearing. If the demand equal to supply and in K1 markets and Pk greater than 0, then demand must equal supply in the K market. Proof if not Euler's law would be violated. Basically, proposition of these three conditions are market clearing, free goods, equality of demand and supply. First of all, market clearing is if K-1 market clear, the last must clear too. In the market clearing, when aggregate excess demand equal to aggregate supply, then market will clear. And free good, when aggregate excess supply less than 0, then price equal to 0, that goods will be free good. Basically, in the free good, if P star is a Wallersian equilibrium and Z of P star less than or equal 0, since price are non-negative, P star into Z of P star equal to summation of Pi Zif greater than or less than 0 and Pi greater than 0, we would have P star Z P star less than 0. That is contradicting Euler's law. This proposition shows us what conditions are required for all markets to clear in equilibrium. Suppose that all goods are desirable in the following sense. Basically, desirability means if price equal to 0, then aggregate excess demand greater than 0. Proof if not Euler's law would be violated. The desirability assumption says that if some price is 0, the aggregate excess demand for that good is strictly positive. Then we have the following proposition: equality of demand and supply. If all goods are desirable and P star is a Wallacean equilibrium, then Z of P star equal to 0. Proof: assume Z of P star less than 0, then by the free good proposition P star equal to 0, but then by the desirability assumption Z of P star greater than 0, that is contradiction. At the existence of Ollerson equilibrium, since the aggregate excess demand function is homogeneous of degree 0, we can normalize price and express demands in terms of relative prices. There are several ways to do this, but a convenient normalization for our purpose is to replace its absolute price P bar with a normalized price. Pi equal to P bar I divided summation of P bar j. This has a consequences that the normalized prices Pi must always sum up to 1. Hence we can restrict our attention to price vectors belongs to the K1 unit simplex. Figures the next slide depict. In the third slide, I will describe Ollersian equilibrium allocation. In this slide, distribution of goods across consumers where each consumer maximize utility at given prices. In the previous slide, we know that market clearing means the aggregate supply equal to the aggregate demand. Here we showed utility maximizing function, and here subject to function equal to P star x less than or equal P star and, and endowment. Market clearings equal to summation of xi star equal to summation of all endowment. In the bottom of right side, we see a figure. This figure means Azure box. Basically, this figure shows uh, where it describe two person endowment and consumption level. In this figure, it also shows the Pareto efficiency allocation, and the shadow line is unique budget line, and in this figure, OM1 to EM1 is the endowment of first person. Here OM1 to XM1 is the total consumption level of first person. From this first person, we can see the aggregate excess demand equal to XM1 EM1. Similarly, in the second case, for the second person, the total endowment is OM2 and EM2, and the second person's total consumption is OM2 and XM2. That is the aggregate excess demand, and that is the aggregate excess supply. Finally, person 1 excess supply equal to persons 2 aggregate demand. That is the Wallerstein equilibrium allocation. Thank you everyone.